Hi, this is section 2.1 on organizing data. And remember when we talked about the difference between descriptive and inferential statistics? We said that descriptive statistics involves the collection, organization, summarization, and presentation of data. And I told you that that was what we were going to focus on in the first part of the semester, or the first part of the course. So we talked some about how you would collect data. Now we're going on to, if you've got some data, you've collected some data values, what can you do to organize your data to make it more meaningful, get a better idea of what's really going on with your data? For example, suppose there's a class of 20 students and here's the list of what they got for their final grades. So this is just this list of letter grades, and it's not really organized, or it's just a list of letters. It's kind of hard to tell what's going on just by this list here. And if it was a bigger class, like 200 students, it would be even harder to tell what was going on just from a big long list of letters. So it might be more meaningful to organize this in something like this, where we have a list of what all the different values on the list are, in this case, all the different grades that people got, and then the frequency, that is, how many of each one of these there was in the set of data. So this is telling us that among these 20 students, there were 5 who got an A, 3 Bs, 6 Cs, 2 Ds, and 4 Fs. So something like this, where we have a list of what the data values are and then the frequency for each one, is called a frequency distribution. So this is an example of a frequency distribution. And one other thing we might want to include in a frequency distribution is the relative frequencies, like what fraction or what percentage of all the grades fell into each one of those categories. Now, if there were 5 A's out of 20 in all, 5 out of 20 is 25% of the grades. You can calculate that by taking 5 divided by 20. And if you do that on a calculator, it'll come up as 0.25. So if you write it in decimal form, the relative frequency is 0.25. If you'd rather write it in percent form, you just move the decimal point 2 places over to the right and say that's 25%. So 3 divided by 20 is 0.15, which is 15%. 6 divided by 20 is 0.3, which is not 3%, but 30%, because you got to move the decimal point 2 places. 10% of the grades were Ds, and 20% of the grades were Fs. Now, one of the questions I asked you guys on that introductory survey was, during what month of the year do you feel happiest? Here are the results I got. Every month was chosen by at least one person, but it looks like the most popular months were October and December. And another question I asked was, how many pets do you or your family have? And here are the responses I got from that. A lot of people said 0, a lot of people said 1. There was one person who had 15 pets. A couple of people left that blank. Before we do that, I've been asking these questions for several semesters now. One of the questions I always ask is, what's your favorite pizza topping? And if I just take one topping from each person, just limit each person to one particular thing, here are the results that I've collected over the past several semesters. So, looks like the most popular pizza topping has been pepperoni. Sausage and cheese are also pretty popular. And then not nearly as popular, but I've also had people say ham, chicken, mushrooms, pineapple, bacon, and various other things. So now let's us try doing one of these. So in this example, imagine these are the animals that people brought into a veterinarian's office to have the vet examine their pet. So we're going to take this just big list of animals and construct a frequency distribution. We're going to organize this into a list of what all the different animals are and then how many of each there were, the frequency. Now, there are various ways we could do this. For example, we could put all of this data into, say, an Excel spreadsheet. And there are ways of asking Excel to count everything up and basically give us a frequency table. And we'll see how that works when I give you instructions for working on the project. There's other computer software that can do this for you, but let's just do this by hand and see how that works. So one way to do this, to make sure you get an accurate count and don't leave anything out, is just go through the list. One item is a cat. So the first thing on the list is a cat. I'm going to write that down here. And make a tally mark there. Then the next animal, the second animal on the list, is a dog. So let me write dog and mark a tally mark for that. Then we have another dog. And next we have a bird. So make a mark for that. Next we have another dog. And then another dog. And then another dog. So far that's 5 dogs. Next animal to come along is a cat. Then next we have a hamster. So that gives us a new category here. So make a mark for that. Then we have another dog, and another dog, and another dog. Notice we're at the end of the first line now. Now we have another hamster. Next comes another cat, and dog, and hamster, and dog, and a dog, and a cat, and a dog, and a bird, and an elephant. First one of those we've seen. So don't forget to make a mark for the elephant. Then we have another dog and another cat, a cat, a cat, a cat, dog, 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 cat, cat, dog, dog, hamster, cat, cat, dog, cat, cat. Now look at what we have here. There are 5, 10, 14 cats. And there were 5, 10, 15, 16, 17, 18, 19 dogs, 2 birds, 4 hamsters, and 1 elephant. So, arranging this nicely in a frequency distribution, here's what it looks like. The list of the animals with the frequency for each one. And if we add these all together, add up 14 plus 19 plus 2 plus 4 plus 1, it's a total of 40. So out of those 40 animals, 14 were cats, 19 were dogs, and so on. What if we want to show the relative frequencies? Well, for this I would get my calculator and I would take each frequency divided by the total, which is 40. So 14 divided by 40 is 0.35. If I wanted to write it in decimal form, it would just be 0.35, or if I wanted to write it in percent form, it would be 35%. So out of all the animals we were looking at, 35% of them were cats. And what percent of them were dogs? Well, 19 divided by 40 is 0.475. If I move the decimal point over 2 places, that's 47.5%. So if I do that with all the frequencies, I get my relative frequencies: 35% cats, 47.5% dogs, 5% birds, 10% hamsters, 2.5% elephants, and that does add up to 100% in all. Now in this next example, imagine you are interested in studying how much people spend at the store, at some particular store that they shop at. So you go down to the store and you somehow obtain a sample, maybe using systematic sampling or something, but you get a sample of 50 customers and find out how much they spend, what their total comes to, rounded to the nearest whole dollar. Like, for example, if somebody spent $20.93, you'd round that to the nearest whole dollar, which would be 21. So for 50 different customers, you find out how much money they spend. These are their totals rounded to the nearest whole dollar. And we want to organize this set of data values into a frequency distribution. But we're not going to want to do it the same way we did the last one, where we say, okay, this many people, or this many of the data values were 21s, and there were this many 43s, and this many 92s. There's a better way of doing it when we have a whole bunch of numerical data like this, and that is to make a grouped frequency distribution. So I'm going to stop this video right here and come back in part 2 and talk about how you would construct a grouped frequency distribution.